Welcome everyone to a Geometry Kuta worksheet tutorial. We're talking about the topic of transformations, geometric transformations, the way shapes change on the geometric plane. But we're talking about reflections in particular here. We're not talking about the mirrors, although that is what it does. It's a mirror image across a specific line. So we're talking about how that works. Now, one of the big principles of line of reflections is we have to reflect it over a specific line of reflections. It would be very good if you guys revisited slope-intercept form so we can remember how to graph these lines of reflection. But just to give you kind of a quick summary, in case you don't have time for that, anytime we have y equals a number, that is a horizontal line. Let me make that a little bit more straight. So we have a horizontal line anytime it's y equals a number. Why is that the case? Because it technically, if you write y equals 0x plus, let's say, 3, or actually let's make it minus 2, just like this one, this first example. That breaks down, that simplifies to y equals negative 2. That slope of 0, the slope is always in front of x, as indicated there, means it goes up 0 over 1. The rise of a run is 0 over 1, so it is a horizontal slope. So that's why anytime you have y equals a number, it's going to be a horizontal line. Now, conversely, anytime we have x equals a number, this is going to be a vertical line. Okay, so that's just a hint to help you out with this. So as we're looking at this number 1, the first thing we always have to do is graph the line of reflection. Okay, so let's go ahead and make this a step here if we're going to break this down. So steps. I'm going to make a purple underline. There we go. So steps. Number 1 is we want to graph line of reflection. Graph line of reflection. That's always the first step. Okay, so in this case, we have y equals negative 2. So it's going to be a horizontal line at negative 2. Another way to write this, as we said earlier, it was 0x minus 2. So we're going to go here. That's our y-intercept, negative 2. And it is a completely flat horizontal line. Okay, now what I like to do, I like to make it like a little dotted line. Let's see if I can get that going here. I like to make it a little dashed line just because that's what a line of reflection does, okay? Now that we have our step 1 completed, we're going to move on to step 2, which is count distance from vertex to line. I'll say vertices because technically we're going to do that with all the each vertex in the shape. Count distance from vertices to line of reflection. I'm going to abbreviate here. Line of reflection. Okay. Now, let's start with Q, for example. So if we start with Q, what is the distance between Q and the line of reflection? Well, it goes up 1 and up 2. Now, this is easy when it is a vertical or horizontal line because technically we need to count a perpendicular distance, okay? So if this is a straight horizontal line, we just have to count straight up using the coordinate plane to get the distance. So we see we have a distance of 2. If we look at Z here, we see that we would have a distance of 3. If we look at E would have a distance of 1. And then look at I. I is zero distance away from the line. It's right on the line, okay? Now, what do we do from here? Well, move on to step 3. Now that we have the distances of each of the vertices, we're going to reflect that same distance on other side of line of reflection. On other side of line of reflection. Okay. How does that look? Well, I'm going to change it to orange. We go 2 units for Q, so I have to go 2 units on the other side. Okay, we went this side. We have to go 2 units on the other side. Okay, it's like a mirror image. So if it goes 2 on one side, it's 2 on the other side. And we're going to label this guy Q prime. That's the new location after this transformation, which is a reflection. So what about Z? Z, we went 3 units to the line, so we have to go 3 units on the other side of the line. Again, if we go vertical to the line, that means we have to go vertical on the other side of the line. This is going to be Z prime. Next, we have E. E is 1 unit away, so we just have to go 1 unit here, and we get E prime. And then This guy, I, is right on the line, so he needs to stay right on the line for the transformation, which is going to be, I'm going to write it on the other side, I prime is right in the same spot. Okay, what do you do from here? Well, now that we've reflected the same distance on the other side, we are going to draw our shape, okay? Which I guess is kind of implied. I mean, you don't really need to connect the dots technically, but you really should. So I guess connect the dots is the last step, implicit step, I should say. So I'm going to connect the dots here. I'm going to use a different color. I don't like it. Use this pink. Okay, so I'm going to connect the dots. And we're going to see how it looks compared to our other shape. Okay, now I'm going to erase this just a second so you can kind of picture it. So look, does that look like a mirror image across? Yes, it does. It looks like it mirrored exactly across that line of reflection, okay? So it's not too bad, but let's continue. So we have reflection across the x-axis. Now, this can be tricky. The x-axis, you might think, oh, x equals a number, it's a vertical line. No, 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 no. X-axis is technically the line y equals 0, okay? So y equals 0 is the x-axis, and then x equals 0 is technically the y-axis. So you have to be careful with that. That is something to keep in mind, and you might need to memorize it, I suppose, or you can just think of it intuitively, but that is very important to remember. Okay, so technically we're reflecting across the y-axis. So I'm actually just going to grab my line of reflection over here, copy, since it's a horizontal line, and I'll put it right on the x-axis right here. Okay, same process. So we've done with step 1. Step 2, we're going to count the distance. So let's go ahead and count here. We have 1, 2, 3 for that guy, 1, 2, 3, 4 for that guy. And then M is just going to be one extra one. Okay, I'm going to go ahead and make that 5 like that. And then 1, 2, 3, 4, 5 again for D. So what am I going to do? I'm going to reflect it on the other side. 1, 2, 3 for A prime. It goes from A to A prime. 1, 2, 3, 4, 5. For D prime, D to D prime. 1, 2, 3, 4, 5 for M prime. And then W prime is just 4. So here's W prime. Last step, I connect my dots. Okay, so it looks something like that. And I just freehanded that one. But you can see that it keeps the distance away from the line of reflection the same, and it keeps the same shape. Okay, it just gets reflected across a mirror image on the other side. We're going to skip 3. That's a tough one. We're going to end with that one probably. I want to get to an x equals. Haha, here we go. So we have x equals -3. So this is a vertical line. Vertical line. So we're going to go x equals -3. That's -1, -2, -3. This is where x equals -3. I should change, it's a vertical line. I was using red for that, I think. So here's my vertical line. And style, I'm going to make this dash like it was before. So there's my line of reflection. This time it's in the middle of the shape. So it's a little goofy, but we still do the exact same thing. Let me show you. So let's go W. W, which way do we go? Well, this time we have to go left to the line of reflection. So we go left 1 unit. Again, we're trying to go perpendicular to this line. So if it's a straight up and down vertical line of reflection, that means we're going to go left and right horizontally. S, we do the same thing. We go 1 that way. This time we're going to go 2 this way for I, and then we go 1 this way for P. Let's change to orange. That means we need to reflect across the line of reflection to get W prime. 1 more for S prime. 2 for I prime. And this time, look how it's going on the other side. If we go right, we need to continue going right. And we do the same thing for P prime. Okay, last step. We're going to connect our dots here. So let's go this blue color. And my I prime, I didn't make a dot for it, so now I'm going to. Okay, so there's my dot for I prime. There's W prime. Oops. I didn't make a dot for S prime either. There's my S prime. And then I connect my dots. And that's what it looks like. See how it's a mirror image? Even though it's goofy and it kind of intersects that line of reflection, it still has the principle where distance is maintained across the line of reflection, and actually creates kind of like a cool little design there. Okay, and then let's talk about this tough one now. So line of reflection y equals negative x. This is technically y equals negative 1x plus 0. So y-intercept is at 0, and I'm going to go down 1 to the right 1. And this is, in my opinion, one of the toughest ways to do lines of reflection. So let me go ahead and connect my dots, and then I'm going to show you how I like to do this problem as stress-free as possible. I didn't do a great job drawing my line of reflection, so I'm going to try one more time. I'm just going to go from corner to corner, and hopefully I can do a better job. Yes, okay, there we go. Style, let's make it dashed. Okay, now, here's the problem. Remember how before I said if it was a vertical line, we'd go left and right. If it was a horizontal line, we go up and down, because we need to get a perpendicular line going. So we can't go this way because that would make a perpendicular angle to my line of reflection. Okay, this would not be a right angle. A right angle would be somewhere like this, and then that would be a right angle. But that is tough to count. It's hard to count that distance because we don't have coordinate plane drawn up that way. So what do? Well, I use a combination of horizontal and vertical components to get to the line of reflection. What do I mean? Well, what I like to do is, you could just use the origin, I suppose, but we're going to target a vertex here. So let's target S. And what I'm going to do is I'm going to count over 1, 2, 3, 4, and then I just keep going 5, 6 until I get to my intersection here. So I counted 6 horizontal, and I get to my new line of intersection with this right here. Now you're probably thinking, okay, but that's not a 90-degree angle. That's true. And if I would reflect it across like that, that would be wrong, because I would not be reflecting it at a 90-degree angle. So what can I do to change that to be a 90-degree angle? Okay, so I counted over 6 till I got to the line. Here's my line of intersection. Now what I'm going to do is I'm going to go down 6. Okay, this is the only difference when you're doing a diagonal line. This is the method that you use. So now we're going to go down 6. 1, 2, 3, 4, 5, 6 to get to my new spot. Again, this is only for diagonal lines. Okay, so now here is my new S prime right here, S prime. Let me do that one more time. Well, actually a few more times, just so you understand the whole process. So A, what are we going to do here? Well, I like to count over first, 1, 2, till I get to my intersection point. Now, because this line is diagonal, I can't just go across, because this would not make a 90-degree angle. Okay, it would be an obtuse angle or acute, whatever. So instead, I go down to create my 90-degree angle, and now I get to my new point, A prime. Again, I counted 2 to the left, and because I go 2 to the left, I have to go 2 down for this diagonal line of reflection to get to my new A prime. Let's do T prime. Hopefully you guys are getting the hang of it. I need to go 3, 1, 2, 3 left, okay, to get to my intersection with the line of reflection. So if I go 3 to the left, that means I have to go 3 down to get to my new location. And that would be T prime. Lastly, I have, and it doesn't matter which order you go in, but now I'm going to go to J, and I just have to move it 1 time to the left, which means I just need to go 1 time down to get to my new location, which is J prime. So if I were to connect all these dots, okay, connecting these dots here, great game. And here's my new shape. So if you guys kind of, maybe I should make it a darker shape. What's the best way to do this? Just so you can see it a little bit better, I should show some darker color. Let me make it like purple or this blue. So you can see it. It's just mirrored across diagonally this time. So I wish I could rotate the paper for you, but it's like that just mirrored across. If you were to put a mirror, it would look exactly like that on the other side, okay? Let me do one more of these diagonal ones just so you can get the hang of it, and then I'm going to end this video. And part 2 will be this down here to create the rules, which actually is a pretty short process. Okay, so let's do line of reflection. This is another diagonal one. Notice how it's not y equals a number or x equals a number. It's y equals x, which technically is y equals mx plus b, but b is 0. So this is going to be y equals 1x plus 0. We're going to go up 1 over 1. That's our slope. Okay, so our line of reflection is going to look like this. Let's make it dashed style, dash line. There we go. Okay, now let's look at L. We need to get over to the line of intersection. So how do you do it? Well, I need to count over. I like to go over until I get to my line of reflection. So I go 2 to the right. Now from here, I need to go 2 down because it's a diagonal line, okay? This only works with y equals x or y equals negative x, for the record, okay? Don't use this against other types of slopes. So my new point is going to be L prime right here. Okay, let's go to P prime, or P. Here I go to the right 1 unit, so now I need to go down 1 unit. Here's my new location for P prime. Okay, I went 1 to the right, so I need to go 1 down. Let's go over here. I go 1, 2, 3 to the right. Now, one thing that's interesting, sometimes you need to go up, and I don't think we went up here in our diagonal line. No, we went down, but sometimes my students are like, how do you know if you go up or down? Well, let's say I count to the right to my line of reflection. If I were to go up 3 and put my dot here, notice how I'm on the same side of the line. Again, you always want to reflect across the line. So don't draw it on the same side. You always want to go across on the other side. So if you go to the right, make sure you go up or down, depending on what it is, to go on the other side of the line of reflection. So in this case, it's down, and that is my Q prime. My last one is H. So H, how far am I going to go? 1, 2, 3, 4, 5 to the right. So I need to go down 5. 1, 2, 3, 4, 5. And that's going to be where my H is. H prime, actually. H prime. And now I'm ready to connect the dots. Make sure, this is kind of the tough part, connecting the dots. Try to go in the same order. So we know P and Q get connected. We know Q to H then gets connected. And then H to L gets connected, L prime. These are all primes. And then I connect those two. So here we have the correct order here. It's reflected at the same distance perpendicularly because we did that correctly, and that's all there is to it. Okay, so this is the end of part 1. In part 2, I'm going to talk about the rules and how to write those rules. I'm going to use reflection notation for that. But thank you so much for joining me. Stick around for part 2.